We present MARLUI, Multi-Agent Reinforcement Learning for Adaptive Point-and-Click User Interfaces. Point-and-click involves actions like clicking on toolbar items, navigating through menus, and selecting objects in virtual environments. Although each point-and-click action might seem straightforward by itself, the overall complexity grows as the number of elements you can interact with increases. The goal of adaptive user interfaces is to automatically change an interface in real time to better support users. Existing methods rely on handcrafted rules, or high-quality user data to map between user input and adaptation. However, handcrafted rules are tedious and error-prone, and high-quality user data is timely and expensive to collect. Furthermore, this means that for every new user interface or task, even if the way we interact doesn't change, there's a need to gather new data or redesign the rules from scratch. The question addressed in this paper is whether it is possible to develop a general framework that allows to easily develop adaptive user interfaces across various point-and-click UIs. We propose formulating adaptive user interfaces as a multi-agent reinforcement learning problem to overcome these challenges and train an adaptive method that is useful for real users without needing real-world data. To understand how this applies to adaptive UIs, imagine designing the look of a game character. The goal is to match the apparel of a virtual character to a target character. The target is a proxy for a normally intrinsic user goal. The user assigns apparel by selecting items in a toolbar. Our method learns to assign relevant items to the limited slots in this scenario. This reduces the number of actions that a user has to take to complete the task. To achieve this, a user agent interacts with an interface to achieve a goal. At the same time, an interface agent adapts the same UI. It must learn the underlying task structure to support the user. Both agents learn to cooperate to complete the task and minimize the user agent's time through a shared reward. Since we train in simulation, we do not need real-world data. In a user study, we replace the user agent with real users. We compare the number of actions a user needs to successfully align the game character with a target in 3 conditions: our method, a static and supervised learning baseline. Our method significantly improves the number of actions needed for real users compared to the static and supervised learning baselines. Please see the paper for more information. To showcase the general nature of our approach, we propose 4 additional usage scenarios in our paper. In the first scenario, the user agent tries to input a number using a keypad. The interface agent can pick from a predefined set of designs. The user agent must learn the correct order of the task. The interface agent learns to pick the fastest interface and reduces the errors of the user agent. In the second scenario, the user builds castle-like structures from blocks in a VR game. The interface agent proposes the most likely block to the user to prevent the user from moving back and forth between the blocks. In the third scenario, the user agent tries to grab an object that is out of reach. The interface agent must infer what the user agent intends to grab and bring it within reach of the user. This task is unsolvable without the interface agent. In the fourth and final task, the user agent edits a photo to match a goal state. The interface agent pre-opens the relevant hierarchical menu for the agent. This reduces the number of actions the user agent needs to take. In this work, we introduced MARLUI, a novel approach utilizing multi-agent reinforcement learning for adaptive point-and-click interfaces, without relying on pre-gathered user data or tailored rules. MARLUI consists of 2 key components: a user agent focused on efficiently accomplishing task-specific goals and an interface agent that learns to support the user agent and real users. We believe that MARLUI, and a multi-agent perspective in general, represents a promising step towards tools for developing adaptive interfaces. Thank you for listening.